Hi guys, hanging out with Pippa. Yes, what do you want to do? Do you want to hear about primary productivity or do you want to go lay on the couch? Primary productivity? Yay! No, probably lay on the couch. You guys can lay on the couch while you're listening. This is lecture 1.6 on primary productivity. It is our last lecture in Unit 1. So let's get going. Okay, so primary productivity is the rate at which autotrophs synthesize new biomass. All right, so that's what you're writing down in your notes. So you should be on page 23 of your notes. That's this page right here. Okay, so you should be following along. Sorry, it doesn't have the page numbers at the bottom, I realize from the copy that I gave you, but it's this one right here. And we'll be taking notes on 3 pages. So this is, you're going to need that page. And then you're going to be doing a little bit of work on this last page here. And I'll be showing you a color picture of that aquatic light penetration, so it's easier to see. So we are looking at how fast the producers, the plants and algae, photosynthesize and how much glucose is being produced. So primary productivity is usually a rate, the rate at which the plants are producing biomass, using the energy from the sun to create organic molecules that then the plant eaters, what the herbivores will eat. So it's a matter of how fast things are being produced. So our first definition is gross primary productivity, and this is the total amount of production of biomass. Make sure I'm out of the way here. Should I move myself? No. No, I don't get to move myself? Okay, I'll stay right there. So net primary productivity is the rate of production of biomass potentially available to consumers, the herbivores. So here's where you got to think about net and gross in terms of economics. So generally, like a good example is that if you have a store, all of your profits are the gross, but what you actually take home after you pay all of your expenses is the net. Okay, so if you have too many expenses, you might actually not make any money and you might go into debt. So that's what we're talking about here. How much does the biome and ecosystem actually use, and then what's available for the herbivores? So basically what we have is that not all of the gross primary productivity goes into making biomass. Some productivity is used in autotroph's own life process, like respiration, and some of the energy is actually lost as heat. So what does this do? Oh, that flips me over. Interesting. Well then. Huh. Okay, sorry. I'm kind of playing with this. No, now you just see all of me. Okay. Oh, there I go. Moving. I want to go over and be with the sun. Yay. All right, so net primary productivity equals gross primary productivity minus R, which is respiration. So the units for primary productivity are, if you're talking about energy, it's joules per meter squared per year. And then if you're talking about biomass, you're added per unit area per unit time. So it'll be grams per meter squared per year. All right. So the energy is joules per meter squared per year, and the biomass is grams per meter squared per year. So remember, when you're talking about time, when time's involved, you're talking about rates. So now let's look at this graph, which is going to show why can't I move me? Yes. an explanation of gross primary productivity, net primary productivity, and then respiration. So over time in a forest, what you're looking at here is that you're trying to figure out what the annual carbon flux is, how much actual biomass is being made that can be used by herbivores. Okay, so you should examine the graph and explain what it shows, including an explanation of gross, net, and respiration. So you should pause and write down an explanation, and I will be telling you a little bit more in just a minute. So please pause. And we're back. So I'm going to tell you what this is talking about here. So the forest age starts off with not a lot of plants. And as those plants grow, they grow at a rate where they actually produce a lot. They do a lot of gross primary productivity. But the respiration rate goes up a little bit more slowly, and then it tapers off. So what's interesting is the net actually reaches a peak early on in the forest's age, and older forests will be stable in their net primary productivity. So what you're looking at here is the difference between the gross and the respiration. So this is a small amount, and then this is a large amount. So the peak of GPP for a forest is when it's young, and after a certain point, it declines and then levels off. The respiration rate of a forest increases more steadily as it ages and then levels off as well. The difference between the GPP and the R is the NPP, which is greatest in a young forest and becomes less as the forest ages. So, factors that affect primary productivity. That's going to be on your next page. You'll be filling in some words. So, the sun. Go ahead and yell it. The sun. The sun or solar radiation is going to affect primary productivity. Temperature will affect it. And generally, temperatures are going to have higher productivity. However, high temperatures can denature enzymes and actually slow things down. Also, there may be high productivity in the cold ocean waters due to the upwelling of nutrients. So these temperatures are for terrestrial and for aquatic. Carbon dioxide amounts. Oh, I didn't want to do that. Okay, let's just go back to the present. You know, it's like really being in the classroom, right? Okay. And water. Water is the fourth thing on your list there. And then if we go on, the fifth thing is nutrients. Any food or chemical element or compound required to have an element live and grow and reproduce. So nitrogen, phosphorus, and potassium, which we will be talking about a lot. Also magnesium, calcium, silicate. And algal blooms are often caused by an oversupply of a limiting nutrient, like nitrogen or phosphorus. Remember the process of eutrophication? And then herbivory. So the grazing by herbivores will lower the productivity, right? But when they're in balance, having herbivores can be good. Therefore, the most productive ecosystems are those with high temperatures and lots of water, light, and nutrients. So what you should do now in your notes is you're going to list the 3 most productive ecosystems that are shown here. And these are shown as the grams per meter squared per area. So a larger biome will have less productivity per area because it's so big, and a smaller biome that is productive will have a more density increase there. So that's what we're talking about here. So you can pause and look at this and decide which are the 3 most productive include both terrestrial and aquatic. Write those down for the 3 most productive. And then for the 3 least productive, let me tell you this, that for the desert scrub and extreme desert, you can put those together. So just say desert. When you add desert and extreme desert, desert scrub and extreme desert together, they're the lowest. Okay, so this counts as one where the other. So you can pause if you haven't figured it out. And now we'll give you the answer. So the most productive are the swamps and marshes and the tropical rainforest and the estuaries. And the least productive is the desert, the tundra, and the open ocean. Okay, so I covered it up. Sorry, that's what I was trying to leave before. Okay, so the open ocean, because it's so big, that is going to, oh my gosh, so I could do this. All right. So humans use, waste, or destroy 20 to 30% of the Earth's net primary productivity. And we only make up 1% of the biomass of the Earth's consumers, which is pretty sad. So, marine, ocean, and producers, these are our greatest friends, okay? So you're writing this down on this page right here, where you're going to write it over on the side here. So for marine, it's algae, plants, and bacteria, okay? So the macroalgae, or the really big algae, the phytoplankton, make up 40% of the Earth's oxygen. Thank you, phytoplanktons. Plants have seagrass, bacteria, cyanobacteria, and chemosynthesizing archaeobacteria, where they don't even need light. And this is to remind you, too, that the algae are actually protists. They're not they are producers, but they're not plants. So they are protists. And then you can see the little pieces here. Some of these are silicates. Okay, so then in the freshwater producers, we have algae, aquatic plants, water lilies, cattails, duckweed, bacteria, and cyanobacteria. I'll show you the duckweed again in my classroom. It's that little stuff that floats on the top. All right, so now you are going to summarize this figure. And that's what I'm going to leave up for you. Let me get myself out of the way of these adorable little fish. Okay, so this is the picture in color, and your job now is to answer these questions here. So hopefully the color picture will help you out. Let me just check something here. All right. So the fish here, the fish that are on the side here are common nocturnal animals. So that's to help you out with that too. All right. So now you can complete the work on page 25, and you are ready to finish the entire packet, because you can do the FRQ, and that we're going to do in some breakout groups and talk to each other about it, okay? Because this is going to be a really good assessment of what you know. The FRQ from 2001, number 2. Thank you.